Welcome to 2.7 quadratic word problems. We've already covered every single thing that you need to know about quadratic equations. Now you just need to know how to do the quadratic word problems. So, first question, we have error analysis. Why is this parabola wrong? We have this equation, as you studied last time, this equation is the intercept form. It's y equals a times x minus p, x minus q. So look at this equation. 4 equals a times 3 minus 1, 3 plus 2, and I'll give you 5 seconds to figure out why it's wrong. Okay, 5 seconds over. So how do we make an equation with this y equals a times x minus p, x minus q form? Well, p is one of the roots of the equation. Q is also another one of the roots of the equations, one of the solutions. So, and we already have our two solutions. It's -1 and 2. This is minus p and minus q. So we do y equals a times x minus -1 x minus 2, which is y equals a times x plus 1 x minus 2. So we have this other point, which is 3 comma 4, so we can plug that in. 4 equals 2 times 3 plus 1, 3 minus 2, 3 plus 1 is 4, 3 minus 2 is 1, 4 equals 4a, and then a equals 1. So a equals 1, so a actually equals 1 in this equation, not. A actually equals 1 in this equation and not 2/5. So the actual equation is y equals x plus 2 x plus 1 x minus 2, not x minus 1 x plus 2. That was the initial mistake that they were having, is because they thought this -1 had to come in there. But we have x minus p, we don't have x plus p, so therefore we have to cancel the minus. So there's minus 1, which is plus 1, which is 3 plus 1, and then 3 minus 2. Next question. The area of a rectangle is modeled by the graph where y is the area and x is the width. Write the equation of a parabola and find dimensions and corresponding area of one possible triangle. What dimensions result in the maximum possible area? So we got our one triangle right here. 1, 6. 1, 6. We're gonna do B first, then we'll do A. So 1, 6 is one of our triangles. So the width is 1 and the length is 6. So 1 times 6 is 6. So then we can draw out our triangle. Draw out a rectangle. 1, 6. And that's our rectangle. And 6. That's as simple as that. Okay, A. So we got one of our points is at 0, 0. One of our points at 7, 0. So we gotta use this a times x minus p, x minus q form. So we do y equals a times. Actually, I can substitute the y like right now. We have this 6. We have this 1, 6. So we can do 6 equals x. It's just going to be x, which I can actually substitute the x. I don't know why I wrote x there. It's just going to be x, and then x is going to be, no, q is going to be 7. So we have something minus 7. We have 1 minus 7, which is -6. So then we can multiply this together. -6a equals 6. A is equal to -1. So this equation has a negative slope, and our final equation is negative. Y equals negative x times x minus 7. So that's our equation in vertex form. Of course, we can make it simpler, but I'm not going to. Now C, I'm going to make it simpler now. So x times x minus 7 is x squared minus 7x. And then you turn it, you make it positive, you make it negative. So x squared minus 7x, you make it negative. You will get negative x squared plus 7x. So we want the maximum possible area. We gotta optimize this. We gotta optimize this equation. In order to optimize it, we need to complete the square. So there's a negative out here. So if you take the negative out, it's a little less annoying. We gotta make sure it's a minus. Okay. So in order to complete the square, I already told you the way to complete the square. Take this number, you half it, 7/2, and then you square it. 7/2 squared is 49/4. So then we add 49/4 inside the parentheses. And then since we're adding 49/4 and we want to balance the equation out, we want to actually be adding 0. So we add 49/4, but we actually added negative 49/4 since it's in this parentheses. We have to add another 49/4 in order to make it 0. So 49/4 minus 7x, we can combine it, equals 49/4. And that's our maximum possible area right there. Maximum possible area is 12.25 meters squared, or 49/4 meters squared. And what's our best dimension? Well, this is our best dimension, 7/2. And then to figure out y, we can just do y 7 minus 7/2, which is also 7/2. So the best dimensions are 7/2, 7/2. And our best area is 49/4. That's how you optimize in a quadratic equation. And if you draw this out, you'll find out that it's a square. It's not a rectangle. Because squares give you the maximum possible area with the minimum perimeter. Next question. Okay, use a system with 3 variables to find the equation of a parabola that passes through -8, 0, to -2, -20, and 1, 0. Friend uses intercept form. Whose method is easier? Justify your answer. Okay, so we're just not going to mess with this system of 3 variables. You probably won't ever need to know this ever. We just have these 3 points and then use intercept form. So what's the intercept form equation again? A times x minus p, x minus q. And we got our 2 intercepts, -8 and 1. So we can plug that in, -8. So x minus -8. I'm just going to plug everything in. We got our 2 intercepts, and then we got our one actual point that we're going to use. So -20 is equal to a times 2 minus p is -8, and then 2 minus, and then q is 1. So we got 2 minus -8 is 10, 2 minus 1 is 1, a times 10 minus 1, divide by 10 on both sides, a is equal to -2. And then we got our two things, so x minus -8, x minus 8, x minus 1 is x minus 1, so x minus -8 is x plus 8, I'm sorry, and then add -2 in there, and then put y equals, and that's our equation right there. Y equals -2 times x plus 8 times x minus 1. Next, analyze the differences in the outputs to determine if whether the data are linear, quadratic, or neither. So we have our price increase in dollars in x and our revenue in thousands of dollars in y. Sorry about that. We have 470, 630, 690, 650, 510. So let's analyze. So we got, as x increases, this is an increase of 160. This is an increase of 60. This is a decrease of 40, and this is a decrease of 140. So it looks pretty promising so far. What we can do is we can find the second difference, or we can just draw this on a graph. So what I'm going to do is find the second difference. So this is the difference. This is the difference symbol. So our difference between 0 to 5 is 160. Our difference between 5 to 10 is 60. Our difference between 10 to 15 is negative 40. Our difference between 15 to 20 is negative 140. So now we find the second difference, which is delta squared. We take this number, we take this number, and then subtract this number. So 60 minus 160 is negative 100. Negative 40 minus 60 is negative 100. And then 140 minus 40, negative 100. Now the second differences are constant, therefore this equation is a quadratic. It's an x squared. And the leading coefficient is negative 100. So the leading coefficient is that divided by 2, which is negative 50x squared. And you don't need to know that, but you do need to know that if you take the second difference out of a table, then you will get a, and if all the second differences are the same, so if it's constant, then you will get a quadratic equation. Next equation, we got 0, 40, 1, 42, 2, 44, 3, 46, 4, 48. Looking at this table, you can instantly tell that it's a linear equation. But here's how to prove it. So you take this difference thing again. So 42, 40, what's the difference? We got plus 2, plus 2, plus 2, plus 2. The first difference is constant, therefore the equation is linear. Next. So 1, 2, 3, 4, 5, 2, 4, 8, 16, 32. Now if you look at the patterns, you'll see it's times 2, times 2, times 2, times 2. It's not a linear function, so neither. But if you wanna be advanced, you can say it's an exponential, because it is an exponential. It's 2 to the x power. If you put 1 in, you'll get 2. Put 2 in, you'll get 4. 3 in, you'll get 8. Okay, let's keep going. So our time in days is 0, 1, 2, 3, 4. Our height in feet 320, 303, 254, 173, 60. So let's do this. 117. Okay, anyways, the differences between these two are 17. I'm going to do negative 17 because you get negative 17 when you do these numbers, and then you subtract this. You get negative 49, and then when you do this, you get I think 254, 173. That's 254. Subtract 81, and then negative 173 to 60. You'll get 113. So if you find the difference between these, it's 32. 32. Wait, yeah, and 32. And since it's 32, since the second difference is constant, the equations are quadratic. And specifically, it's negative 16x squared because you take this divided by 2. The table shows the height of y, y of a competitive water skier, x seconds after jumping off ramp. Write a function that models the height of a water skier over time. Once the water skier 5 feet above the water, and how long is the skier in the air? So we got our equation. We have one of our intercepts right here. We can figure out our other intercept. Maybe we might be able to figure out our other intercept. But when x is 0, the height is 22. We can take our vertex right here. We can do vertex form, right? Yeah, let's do vertex form. So and one of the points. So our vertex is 0. Actually, we don't even know if this is actually our vertex or not. Okay, let's assume this is the vertex. Okay, so let's do 0.25 0.25, we got y equals a times x minus h, x minus 0.25 squared plus 22.5. So we have to plug in one of the points. I'll plug in 0 and 22 because that's easy. So we got 0.25 squared plus 22.5 is equal to 22, and we have a here. So 0.25 squared, 0.0625, and then we got subtract 22.5 from both sides. We got negative 0.5 is equal to 0.0625. A, so divide by 0.0625 on both sides. You will get a is equal to negative 8. So then our equation is y equals negative 8 times x minus 0.25 squared plus 22.5. But we want to know when the water skier is 5 feet above the water. When the water skier is 5 feet above the water, the height in y is 5. So we can put 5 in there, we can figure it out. So let's do that. Negative 22.5, subtract 22.5 on both sides, you'll get negative 17.5 times negative 8, x 0.25 squared. Add 8, divide by negative 8 on both sides, you will get 3 over 16. 3 over 16 is equal to x minus 0.25 squared. You take the square root of both sides, which should get you this should get you about 1.48 or 1.47 roughly, equals x minus 0.25. Add 0.25 on both sides, you'll get 1.72 is equal to x. So 1.72 seconds roughly is when the skier is at 5 feet. How long is the skier in the air? So the amount of time that the skier is in the air is characterized by the amount of time that the skier is higher than 0. Therefore, we gotta find it when y is equal to 0. So we'll do the same thing. We'll do 0 instead, so we can instantly move that over. We have negative 22.5 is equal to negative 8 times x minus 0.25 squared. So we do divide by negative 8 on both sides. You will get to 13 over 16 is equal to x minus 0.25 squared. Now 13 over 16 is, I think, 2.82. So the square root of 2.82 is roughly 1.68 is equal to x minus 0.25. Add 0.25 on both sides, 1.93 is equal to x. So he'll stay in the air for roughly 1.9 seconds. Okay, last question, question 36. I don't even need to erase all of this actually. Use a graph to determine whether average rate of change over each interval is positive, negative, or 0. It's kind of obvious enough. So from 0 to 2. From 0 to 2. Is it positive, negative, or 0? Well, it's clearly positive right here. From 2 to 5. 2 to 5. Positive, negative, or 0? It is very negative right there. From 2 to 4. 2 to 4. Negative as well. And from 0 to 4. From 0 to 4, 0 is right there, and 4 is right there. So it's a 0. There's no rate of change. It looks like it's going up and down, but it's actually a 0 rate of change. So that's going to be it for today's video. Bye.